Welcome to today's discussion, which will be around the introduction to the NodeMCU device. I'll demonstrate it in front of the camera so you can see what it looks like. It's a very beautiful device, and we'll go into the details of it, but it's a simple USB device that connects to your USB port, but you probably already know that. Where to begin? I have a board set up just with a flashing LED over here. I will maybe should just draw the circuit so you can see what that looks like, and that is connected through to two pins on the device. One is ground, which is a black cable, and the other one is a pin output, which is pin 1 on the device. So it's just basically going through the breadboard and
so
back.
will be those ones or those ones?
Well, yes, on this one, this is the bottom where the USB cable pops in. It'll be between the black ground and GPIO1 in this case. So if we're looking at it from here, that's the same layout. It's the second pin up.
Here, this one?
This side.
Oh, this side?
Yeah. So this is a top.
Oh, yes.
Yeah. So there they go there, just like that.
Okay.
Okay. Right. Maybe I should just first explain how the pins are connected and why there's a resistor there, etc. Out of the MCU, there is a couple of pins. One of them is a ground pin, and the other one is a digital out, which is 3.3 voltages. That it can be 0 or 3 volts. We have on the ground pin, we've got a resistor, and we have an LED. Circuit. Very straightforward.
So that's you connected through the breadboard?
Yes, I'll explain the breadboard as well. I should bring it next as well. But essentially what you want here is when current goes through here, an LED current flows in one direction, conventionally speaking or non-conventionally. But you need a resistor in the circuit so that you don't supply too much current to the LED, otherwise
you flow in the wrong way.
Real flow is this way, conventional is this way. But yeah, ignore that for the moment. If the LED needs to be connected a certain way, otherwise it acts like a diode. A diode goes in one direction only, the current. If you look carefully on an LED, from the top, for example, there'll be a circle, but there'll be a flat part at the bottom. You can't see it, but there is a flat part, and there'll be a pin at the bottom and a pin at the top. The flat part is the minus connection. Okay. And the other one.
So minus goes to ground? Minus
goes to ground, so this will be flat physically on.
Okay.
To the thing.
Great.
We can take a close look later. So the resistor limits the current through the LED. Very simple. Now, breadboard. I don't know how we're going to do this. Maybe this way. Typically, a breadboard has got a lot of pins going this way. Then there are pins going like this, across like that, all the way through the breadboard, and another bank of pins going like that, and another rail at the bottom. Normally there's 4 holes that you can put your components in, and those holes are electronically connected together. So if you have a cable, you can plug it in here. You can put a component in here, like a resistor, for example, and you can put it into there for the next thing, and they can go somewhere else. So that's the basics of a breadboard. It's very simple.
So what it just does is spare you the time of soldering.
Yes. So usually you want to verify your circuit before you do it. You put them all together like this.
Yeah.
So you usually use these for the power. So you might put 5 volts or 3 volts in here.
I was expected to see a final product.
No, nothing. This is basics. This is very basics.
Stuff.
And your ground will be over there, for example. So normally you put the power on the little rails.
Yep.
And then you put your components in the middle. The Arduino IDE this is pretty much a copy of the Arduino Code for the MCU, what's called NodeMCU, and it works in almost identical way to an Arduino. There are 2 main functions you get when you write a program. a setup, which does setup, and a loop, which loops forever. So the setup will set up all your pins and your variables and stuff, and the loop will just run something and repeat it forever. Okay. So in this case, we're connected to this pin over here, as I said before, GPIO1, which is pin is 1 on the in the board. So GPIO01 over there. So we have pins can be input or output or analog, but that's another story. So pin number 1, we are setting to output. This is very
so the pin that is here
yeah.
is gonna transmit information over the breadboard.
It's going to set the value of that pin to 0 volts or 3.3 volts and high.
Okay. To that
that LED, yeah.
E
That's right, yeah.
Sorry, to the white one.
Yeah, that's right. And then we're simply entering a loop which will run forever, as I said. And there's a new command called digital write, and that is a digital write. You tell it which pin, and I'm just passing in true. You could pass in 0 or 1 or something else, but typically true or false is fine. So we're writing 1, we're making the pin high. We are delaying for 100 milliseconds, which is 1 second. We are writing to the pin false, turning it off, delaying for 100 milliseconds, and repeating it again and again and again. Very simple program, yeah?
Okay.
So, in the IDE, this is a very simple IDE. There's 2 options. There's tick, which is compile or verify, which compiles the sketch and tells you information which you might want to read at some point about how much space your program took up, how much space is available in the device, etc., which is quite useful. But the magical button which you're after is this one here, which is the upload button. When you've written your code, you can press that and it will actually upload the sketch to the device. You'll see that the LED on the device starts flashing. And it's writing the program. You can see the dots going crazy there. When it's finished, it'll actually start running. And that's the LED is not flashing this time because it's writing. And then you'll see the programs, the LED starts flashing. Woo! Woo! That was fun. That's your first project. Now, we have taken our loop and the time to our delay time down to 100 milliseconds, which is 1/10 of a second. And as you can see, the LED is flashing a lot quicker. This brings up an interesting point. You notice there's an LED on the MCU. It is connected to pin 1, but it will only work when there's no web server running on the device. So that's why we have an external thing connected to our external LED. Right. This is the end of the first lesson. Very exciting. We can move on to another topic if you like. Next lesson.
One question.
Yes, questions from the audience.
What about that LED there?
Yep.
Can be a bulb, like a normal.
Well, yes.
So that, will that be enough power to?
Absolutely not. No.
No.
This is obviously very low power. The MCU draws 0.25 milliamps, which is very low. Maximum current. You would have to take this output and connect it to a transistor and potentially a relay to power something bigger. I can draw you a quick circuit if you want, because I have done this before. Out of the MCU comes a very small amount of current, and there's no ways you can switch mains power. So what you can do as a first level is you connect to a transistor or there's another device, MOSFET, but a transistor. Basically, a transistor acts like a switch, really digital switch. So you can, for example, have 12 volts coming in here, and a small current here of just 3 volts would be enough. Will basically turn this, make current flow in this direction. 12 volts with quite a bit of current.
So you're changing that LED that you have there for that transistor.
Yes.
Okay.
Essentially.
And that transistor is gonna give another point, and you connect a lamp if you want there.
Well, not exactly. That'll be if you've got a 12 volt thing. Theoretically you could, but this isn't the right component for this.
Okay.
But let's say you got a 12 volt supply. There's another component which is a relay, a digital, which normally runs on about 5 volts. 12. Let's say it's 12 volts in this case. Inside it there is a coil, and there is another switch inside the relay. What happens is when there's current flowing through the coil, the switch will turn on. It looks like a magnet. Will turn a switch on like a light switch, and with that you can run 240 volts. And then you can have a light bulb, which is a 240 volts light bulb.
Okay.
Okay. One more component you'll need here is another diode, but that's probably
What's that?
too much information. It's just an extra component.
Okay.
when you put current through a coil is just a wire that's curled up. It acts like a spring on a car. If you push it down hard and you let it go, it comes back at the same force you put into it. So if you push 12 volts down here, 12 volts will come back around this thing and into your MCU and kill it. So this is like a short circuit. So that if you push down, it'll come through here rather than through the rest of the circuit. But it's just information. But this is a simple circuit of where you could get your node to turn on a water pump or a light or TV or anything with that solution from a simple digital input, low voltage to that. Okay. Finish the first level. Let's move on to the second level. The second demonstration is basically we want to make the LED, instead of turning on and off digitally, we want it to come on gently and go off gently.
Dim.
To dim or go, yeah. In this case, we're going to make it throb like a heartbeat. So the problem is that on the NodeMCU and most MCU devices, the output is digital. And it actually doesn't, so it doesn't send, it'll only send out 3.3 volts or 0. It won't send anything in between. Now the way that we fix that is we looked at something called the duty cycle, or in this case duty cycle. So what you can do is you can take a square wave, 0 and 1, and turn it on and off very quickly, typically faster than your hearing age, maybe about 40 kilohertz, maybe more. And your percentage of your on time versus your off time will produce an average, which is between 0 and the top. So by doing this, you can simulate analog outputs. So if you want 1 volt, you would have it on for a third of a second and have it off for 2/3 of a second. So 3.3, you know what I mean. There's a formula for doing that, but I won't go into the details right now. Here's a simple illustration. If the output is 3.3 volts and you have it on for 1/100th of a second and off for 99, you will get 1.3 volts multiplied by 0.001 or whatever it is, the output. And if you have it on for 99% out of the time, thank you for supplying some chips for us, sir.
Thank you.
If you have it on for 99% of the time, you'll have net close to 3.3 volts. So it's a simple thing. Okay, set up the standard input output as before. So here we go. Let's go through this code. Very similar to the first one. I'm just adding a variable in here for the pin because it's better. You can set up constants and variables outside your loops, which will be used as global variables. Yeah. So in this case, same pin we were using before, pin 1. I'm just using a variable. So
okay.
Pin mode. So pin mode, pin 1, which is there. Output. Set it for output as usual. And almost the same, except what we're using is using a different method called analog write. And analog write, as I said, isn't really analog. But what it does is it accepts a pin that you want like to output, and it accepts a value between 0 and 255. 255 equals completely on, and 0 equals completely off. 128 is half power. So on average, the voltage will be 1.5 or 1.6 or so volts if you set it to half, basically, so average half. The nice thing is that the Arduino software sets up all of the magic internally, sets up the pulse width code so that it actually outputs the pulse widths to the pin automatically.
Okay.
Very simple. So what we're doing in our code here, we're going from 0 to 255. So we're ramping up from no light to 100% light, but we're just doing it quick, a little bit quicker with 5 steps of 5 jump. So we're delaying for 1/1000th of a second in this case, and writing that output to the pin. And once we've done that, we're going from we're just doing the inverse here with the 255 minus x. So same loop. I just couldn't be bothered writing the for each loop again.
Yeah.
But this time we're just going down by, or going up by 1 increment. So it's going to go up fast and down slow. Once it's done that, it's going to wait for half a second and throb again. So let's take a look at how that works in action.
So what you're gonna do now is just update the code that you put in the first lesson.
Yep.
Okay.
So I mean, you can have multiple sketches open. I've done it at multiple at the moment. There's the next one there, and you can just click on the upload for the one that you're interested at the moment at that time.
Yep. Looks like it's uploading something.
Yep. You can see at the bottom here the dots as it goes through. Oh, cheese
This is
curls.
front item because fascinating if it is.
Not really.
No.
It's a bit dark in here. Maybe
Not
you can turn-
really. Really.
Can you turn off the lights for a moment, sir? Just briefly, outside the door. Now it's probably better to see now, but you can see
Ooh.
the LED is flashing. What's really happening here again is that the LED has been turned on and off very quickly, so fast that your eyes can't see, and we're sort of blinking like a heartbeat. So very nice. It's very easy to do. So we could have a motor turn at different speeds, for example. It's very popular. You'll notice if you've ever seen an electric car or electric motorbike pull off, you hear they make that whining sound when they pull off. They go like it sounds kind of weird, like a high-pitched noise.
Mm-hmm.
They're using the same technique in those cars to turn it on and off very quickly and adjusting the pulse width. Right, any questions?
How many LEDs
Lights on, please.
can you control with one node?
Well, you can control as many as the digital outputs on the in the diagram.
So in this
Things you've
case,
got.
16, something like
Have
that.
you noticed there's a little PWM
Yes.
symbol at the top of the diagram? It's like a little tilde sign.
Mm-hmm.
PWM stands for pulse width modulation, and the ones with the tilde sign next to them are the ones you can have the analog output on. So D1, 2, 3, 4, and
9. D9 and D10.
D1 is what we're on now. It's got a little tilde sign in front of it.
D1 or D10? D10.
Oh, it says D10 there, but it's GPIO 1.
Oh, okay.
Yeah, just internally in the code, it's 1. So they're just named differently. Just out of interest, there's an analog. There's only one analog input in here, so you could have an input like from a microphone or something like that, or whatever to get a voltage input. This side of the board is not connected or has some output voltages that you can use, reset and etc. So you should generally not using that side of the board. The inputs are all down here.
Okay.
It's easy to connect another component outside, like another chip, and then you can multiply the outputs quite easily, or the inputs, but that's another subject for another time. Right.
Cool.
Now, for the final presentation, I want to go to a whole nother level of complexity. We're going to create a web server.
Oh my god.
Oh my goodness.
This is getting good.
I'm not going to go into too much detail, but I'll run through the code. Essentially what I've done is I've created a web server which you can turn the LED on and off with from a web page. Whew, hope it works. Anyway,
all this code is gonna be available in our beautiful GitHub account by the weekend, right?
I've already given you a copy of the code.
Oh,
okay,
good.
I have the password here, which I'm going to have to blank out in the video, obviously, for the Wi-Fi connection.
Oh.
And the password, the Wi-Fi password. So let's have to scroll that out so we don't have to worry about it.
We don't want to share that with the whole world.
We have a ESP8266 web server, which is the chip that this NodeMCU runs on, running on port 80. Again, we've got to change the port. I mustn't forget that.
Our next weekend, guys.
Bye.
Don't get electrocuted.
Thanks for coming. I've just given myself a note that I need to connect to a different GPIO pin because this LED is the same one that's used for the web server. So I'm moving to a different pin, which is D1, which is up here on your sheet, just so that we don't interfere with the blue LED on the device, which is the web server pin, status pin. So there we go. Okay, so again, now we're in a different pin. LED 5 is the LED is the pin, it's the pin. That's where the LED lives. Right, setup. Set the LED to output as we had before. We've got a new thing here called serial. The device can send back serial output debugging data and this baud rate to the IDE, so you can see what's going on for debugging. Very useful. Here's an example of a debug statement. Serial print line something. How are we going to see the output? We've got a little serial monitor over here, which will open up once this is running, and it'll output whatever we have to a console, just like a console terminal window. So that's just that. But the Wi-Fi, we have a Wi-Fi, and we're saying begin with the username and password, which we said previously. That will set that up. This code I've copied, so I'm just going to breeze over it because I don't know too much. Basically, this is going to try and connect to the Wi-Fi connection and wait half a second, and then try again. This is unnecessary. It's going to output a dot. Bye. It's going to output a dot every time it tries to connect, so you'll see that it's actually trying to do something. Okay.
Very boring.
Very boring.
Very boring print that you did.
Yes.
Okay. Because we didn't have dots before. So.
Yes.
Oh my god.
You'll see why when it runs how it actually works.
Okay.
If it gets out of this loop, it's actually connected to something, which is very exciting.
Yeah.
And say connected to, and it'll give you the details. Well, in this case, SPN, and it'll give you the IP address, which is all important with this command here, so you know what to connect to. Okay. It will then, I don't even know what this does. Begin something. I suppose that's probably the web server. No. Once we've done that, we can set up the web server to have some callbacks. You'll be very familiar with this with JavaScript. So, on /, which is a request to the root of the server, call this method handle root. It's a function which is defined down here, but we'll go through when you get there. So in other words, when you get that, run this method. When you get LED on, so web address /LED on, handle the LED on and off again. If you send something else to the web server, it'll just give you a 404 saying it's not found. Server begin, start the server, and output the debugged HTTP server has started. How exciting. Right, here's the loop, which is very straightforward. Forever, handle a client request. Okay? And do
Forever,
it
you said?
Do it forever. It's in the loop.
Oh, okay.
It's in the loop. So handle a request. If it doesn't get anything, it'll just loop and loop and loop forever. Important to note that the NodeMCU can accept one connection at a time from a client. It's not a massive web server. It can just take handle one person at a time. So, yeah, very simple, but effective. Right, as above, we've got the slash, which is the root. When you load the page for the first time, calls this method, and we generate in the string page, we're just generating an HTML document. Very basic and straightforward. So there's HTML, we are adding the header information. I've just got this one refreshing every 5 seconds. It's not really necessary in this example, but it'll just keep refreshing.
Okay.
Here we go, pin status, and it'll look at the state, which is a global variable. So that's the state whether it's true or false. So if it's true, in other words, the LED is on, it will output a simple link with the color green and the text on. And same if it's off, it'll just say the word off. And that's your HTML document finished. And it'll send, so to the server, send a response back. 200 is the status code, okay. Send text HTML. You can set text or any other content type you like, and then the payload. And then debug the output. So, very, very simple web server page requests.
Sorry, the state, I lost.
So again, the state is a variable which we set at the top here.
Oh, it's true?
Which is true. And that is just the LED starts in state true, which is on. So that's just to keep track of what the LED was.
And you are printing a link to let off to
right.
change it there.
A conditional thing for on and off. So if it's true, it's on. If it's false, it's
and
off.
then you're gonna change the URL when you click there.
Yes.
Okay.
So when you click on, it'll turn it off. When you turn it off, it'll turn it on.
Yeah.
It's just a toggle, really. Very basic. You could add in your Node.js or, your Angular code or whatever you like, but this is just very basic. So that's how you produce a home page. When we hit the LED on, if that link is clicked, which we defined above again here, so LED on. So when that URL is hit, this method is called. The state becomes true. We write the state to the pin. We tell the output what we've done. Wait for the recorder to come about. Okay, we wait for the. That's all good. We wait for the. So we tell the output what we're doing. We send the header location. So in other words, we've set the state of the LED already. So we tell the server that we want to just go back to the home page with the header redirect to local. We set a temporary redirect. HTML, we just output done, doesn't have to output anything. So all that's going to do is set the LED and then return to the home page.
Yep.
In a very similar fashion, we're doing the off thing, state is false. The not found does copy and paste code from somewhere else, which I've shown you before, and returns a 404. Okay, now for the important demo. Let's bring this to the MCU and see what happens. What's this? Building. This one, it usually takes a little bit longer because it's got to download the whole web server to the web server code to the device. So.
You have the last one.
Oh, thank you. That is the last one. It's currently writing. Now remember we had the debug console here. When it starts running, I'll click on it. So we're still loading at the moment. Hopefully. We'll try. Here we go. Here's the outside. Remember the dots we had earlier? So these are your dots. It's trying to do its thing. Now it's telling you that it's connected to SPM wirelessly.
Woo!
And the IP address is this, which I'll copy. And it's just telling you that the web server has started.
Nice.
Beautiful. Now let's go over here.
You're gonna have to trim smaller. Make it small.
Okay, smaller window.
Oh.
Edit that out, please. Some code, big code. So if we go here, theoretically, we should have a web page returned, and this is coming from our MCU device. We have the link. So we click on the link, and nothing happens.
Boom.
Okay, well it's
What?
that's right.
There you go.
Now it's on. Click again. Now it's off.
So the
So status is off.
Their
at the moment.
status are the other way around, inverse.
We need to change the logic from off default.
Good.
Status. And there we go. We can turn it on.
We
turn
just
it
need
off.
to change the names.
Yeah. Turn it on and turn it off. That was pretty exciting. So we've gone to this state where we can do lots of things. We can do lots of things from here. But so what have we learned? Any questions so far? First of all,
No questions. Very
no
clear.
questions.
Very
Great.
clear.
Okay, good.
I get lost with the where are you setting the pin there, but I will recheck the video again later.
Video again.
Yeah,
So the pin has been set here.
digital right.
Digital right, yeah.
That's where the NodeMCU push data to the LED.
Yes, that's right.
Okay.
So and of course the state just changes for
Yes.
that. Yeah.
Yes. Okay.
Yeah. It's just you take a look at this code and you'll get it in 5 minutes just reviewing it.
Yep.
But
So right now, I could connect to that same URL in my computer.
on your computer, you could do exactly as anybody in the office could connect in that same URL.
But you said before that only handles one.
One connection at a time.
Yeah. So what if I
Concurrent connections.
what if I connect now
You can connect now. It's fine.
and it will work?
It will work. Yeah.
So what do you mean like only handle one connection? That's what I
If
don't
we were
understand.
both making the same request at the same time,
Okay.
it would one of them would not work.
Yeah, but that will be a little bit difficult. Well, not that difficult if there are 100 people connecting, trying to do something.
Yeah, so you can't run an application that serves multiple users
Yeah.
on it. Typically, you would just do a simple JSON request to it or something to turn something on or off.
Yeah.
And have some other web server running that would do your bidding.
Yeah. Okay. Sweet.
So with that, I think I'm going to leave it, close up the session, and we'll see you all next week. Thank you very much.
Yes.
Bye. Stop recording. Save.
Mr. Matrix.